Is it possible to charge electric vehicles without cables? The answer lies underneath this car. In Zaragoza, in northern Spain, scientists have developed an innovative charging station for electric vehicles. The charging takes around 20 minutes, but unlike other stations, this one is wireless.
The system works with coils that are buried under the tarmac of the charging station. It's using inductive technology. This coil is energized from the electric grid. When the vehicle is positioned correctly on the charging station, a connection is made between the coils and the car. The coils transfer energy to the car. It's a very flexible, modular system. You can charge cars, vans, or electric buses.
Researchers say this method is easier, safer, more vandalism-proof and has less visual impact than charging with cables. Now they're turning to industry to help complete the testing.
As far as the electronics are concerned, we've developed 99% of its full potential, and we already have what's needed to produce an efficient wireless charging station. The remaining work concerns coils. That's where we're lagging behind. We need to find coil manufacturers interested in this product, but these coils are so innovative that it's still hard to find those manufacturers.
The European-backed research project also aims to convince the public of the benefits of electric vehicles. But firstly, there are major technical challenges to overcome.
The first one is to do with communication. That is, how to make operable the communication between the car and the infrastructure. Then there's the level of energy transmission. That is, how can a 3.7 kilowatt car be charged at a 50 kilowatt charging station? And finally, we're addressing the problem of positioning, because positioning the car correctly, that means positioning the coils under the station in line with those on the car, that has a big impact on charging efficiency.
So how can drivers get the full potential of this technology? The answer lies in developing a system that assists drivers to position their cars exactly over the charging coils so no energy is wasted. The engineered solution involves magnetic fields, optic systems and algorithms.
At the end of the project, we're now at a point where we can say that with a camera and a radio frequency identification support system, we can enable a driver to approach the inductive charging system in the correct way.
More research is needed to increase the charging station's potential and to optimize its operability.
We're working at a given frequency, but in other countries they can be working with a different frequency, so we need to harmonize those. We also need to agree on the size of the coils, on the distances of electric emissions. All this is needed for the system to be fully interoperable. I think as far as cars are concerned, we're very close to a serial production. That is, I think we'll see cars that are equipped with this technology within the next 1 or 2 years.
And the next big issue, the researchers say, is how to develop a dynamic charging system that will allow vehicles to be charged on the move on motorways and streets.